Hi everyone. Today we are going to discuss about protecting group. So in organic chemistry, everyone heard the name protection of functional group, right? So today we are going to discuss about the protecting group. What do you mean by protection? Like protection of functional group? It is means like if you want to react a less reactive functional group in presence of a highly reactive functional group, you need protecting group. So what do you mean by this statement? So if a substrate contains these two functional groups, so what is that functional group? It is known as ketone and this one is ester. So if someone want to reduce ester in presence of ketone, what do you need? We need to protect the ketone group. So what is the order of reactivity? Order of reactivity of the carbonyl group is acid chloride, highly reactive, then aldehyde, then ketone, then ester or amide, then carboxylate, that is carboxylic acid. So if we add a reagent like lithium aluminum hydride, so what it is do? It is a nucleophilic reducing agent, right? And it is a strong reducing agent. So if we add lithium aluminum hydride to that substrate, it reduces both the functional group. If I intentionally want to reduce the ester only, so what I do? I have to first protect that ketone with a some specific protecting group which is inert to lithium aluminum hydride. Then the lithium aluminum hydride only reduce the ester part. So what is the functional group I choose? So we have to choose 1,2-diol. In presence of acidic condition, it protect the carbonyl group of ketone, and after protection it will form this type of substrate with the ester group free. Then when we add lithium aluminum hydride, then it will reduce the ester only. So though lithium aluminum hydride is a strong reducing agent, it reduces the ester to what functional group? Alcohol functional group. First it reduced to aldehyde, then aldehyde to alcohol. After that reduction, if you want to deprotect the functional group, we just need to add acidic condition. In acidic condition, that protecting group is deprotected and we will get this alcohol. So what we get? Initially we take beta keto ester, now we are getting beta keto alcohol. So what you observe, like ketone remain unchanged and the ester group converted to alcohol. So we reduce the less reactive functional group in the presence of a strong reactive functional group. So for that we need that protecting group. So there are different criteria to choose a protecting group. So what are the criteria? The first criteria for a good protecting group is selectivity. Selectivity means kinetic chemoselectivity. everyone know about that chemoselectivity, right? What do you mean by chemoselectivity? If two functional groups are there, the it is more specific towards a specific functional group, that is called as chemoselectivity. And kinetics means very fast reaction, so it is like selective towards a specific functional group and it will react very fast. The second criteria is easily deprotected. So at the end we need the deprotected one, right? We protect because we need to react the less reactive functional group, but after that we need the substrate like before. So the third one is like it should not have any additional functional group. Any additional functional group. If it contain any additional functional group, it may react and it will leads to a number of side product. So that criteria should be followed. So let's start about the fast protection of amine. So how to protect amine? What do you mean by amine? There are three types of amine: primary amine, then secondary, then tertiary amine. So primary amine is like nitrogen containing two hydrogen. Secondary amine means nitrogen contain one hydrogen, and tertiary amine is nitrogen contain no hydrogen. So out of these three amine, the primary amine is so reactive. So if we want to protect the primary amine, what are the protecting group we have to choose? So why it is required to protect the primary amine? So it is like it is very easily oxidizable. It can easily react with. Uh, it can take part in metallation reaction. What do you mean by metallation reaction? If we add like n-butyl lithium to this amine, then what will happen? So it will form a metallated product plus butane. So and and the nitrogen of that primary amine contain a lone pair of electrons, so it can easily act as a nucleophile. So to overcome this problem, it is required to protect the primary amine. So what are the protecting group? So first one is benzyl protection. Benzyl protection of 1 degree amine. So CH2PH. So this is known as benzyl, and it is represented as Bn. Bn means benzyl. So how to protect? So when like a compound containing a primary amine, if you add benzyl halide and any base like sodium hydride and THF, then what will form? It will form initially it will form one benzyl group. Now this again nucleophile, it will attack with one more molecule of benzyl halide, then it will form dibenzylated protected form of primary amine. But if we add a secondary amine with the same condition, then what will form? It will form a benzyl protected amine. Then how to monoprotect the primary amine? To monoprotect, what we have to do? take a primary amine, then first react with formaldehyde, then it will form this. After formation of that intermediate, you have to add sodium cyanoborohydride. Then it will reduce that imine to form. If you want to do the benzylated product, so you have to take benzyl halide. Then it will form like this. Monoprotected amine. So after protection, we also need to deprotect it. How it will deprotect? So for deprotection, so we need palladium over carbon and water. So what is it? What this combination called? It is known as hydrogenolysis. So any compound containing benzylic or allylic group, it will hydrogenolyze at that position only. Like our protected compound is this one, right? That is secondary amine benzyl protected. So this is known as benzylic position. So when we use that condition, that is hydrogenolysis, it cleave that bond, the carbon, that is benzylic carbon and that functional group. So it cleave the bond between the nitrogen and that benzylic carbon. Then the product becomes amine and your pH CH3. What it is called? It is called as toluene. So this is one of the protecting group of amine. So the next one is, sorry, the next one is amide protection. So everyone knows about that functional group. What is this functional group called? It is called as amide functional group. So how we will form a amide protecting group? So let's take a secondary amine. Try to react with acid anhydride. What is acid anhydride? This is the chemical structure of acid anhydride. So the nitrogen has the lone pair of electron. It will attack to the one of the carbonyl carbon. Then the bond electron will shift like this, and it leaves a acetate ion. And form acetate ion, and it will form so as nitrogen contain 4 bond here, so one positive charge should be there, then that proton will lose like this minus, okay, the bond like this because nitrogen already contain a positive charge, so both the electron of that bond will shift toward nitrogen. Now it form amide and it leaves as a H plus ion. Then this H plus ion and this acetate ion both combine and form what? Acetic acid. So by this process we can protect a amine with a amide protection. This is called amide, right? Nitrogen and a carbonyl group. So after that formation of amide, we need to deprotect also. So how to deprotect? So for deprotection, we need divalase. What is divalase? Divalase is diisobutyl aluminum hydride. So this is the chemical structure of divalase. This is a hydrogen. So that amide will reduce to amine and get deprotected. So what is the next functional group? Sorry, next protecting group. So third one is carbamide protection. The chemical structure of carbamide is this. So this is called carbamate and this structure is amide. So what is the difference between carbamate and amide? The difference is only here it contain a ester group and here it contain only a ketone group. So how to form that carbamate? So for that we have to react a amine with this species. What it is called? Alkyl haloformate. Or maybe your methyl or ethyl, and this species is known as alkyl haloformate. So how it will react? So the nucleophile will attack to the carbonyl carbon, then the electron goes to oxygen, again come back and that allied group will leaves. Then what will form? Your this species will form. After the formation of this species, one of the hydrogen leaves H plus ion and it form your carbamate. So carbamate, this is the way how we will form a carbamate protection of amine. So after the formation of carbamate protecting group, we need to deprotect it. How we will deprotect? We can deprotect with the presence of iodo trimethyl silane, that is CH3 all 3. This is the reagent we need to deprotect the carbamate to amine. So there are two most famous example of carbamate protection group. So one is your CBZ, and another is BOC protect. So what is CBZ stand for? It is benzyloxy carbonyl, and that one is tertiary butoxy carbonyl. So how it seems like? What is called? When it contain a carbonyl, so it is a carbonyl. Now benzoyloxy. So see, this is benzyl group and this is carbonyl group, and this is known as CpZ protecting group, and BOC is tertiary butoxycarbonyl. How it seems? It seems like this. This is the BOC protecting group. So how we can form that protection of amine? So let's take an example. We need to add the halide form of CpZ, then one base triethylamine, then the solvent is trichloromethane. Then that lone pair of the nitrogen will attack to the carbonyl group, electron goes toward oxygen, again converts, and the leaving group leaves. Then it will form your this species, right? Then H plus leaves, and we will get CpZ protected amine. Similarly, for BOC protection, we need an amine and need BOC anhydride. Mm, The chemical structure of BOC anhydride is like this. So the lone pair of nitrogen will attack to the carbonyl group. It goes over oxygen, again it comes back, and this group will leave. Then we will get your BOC protected amine. So after protection, we need to deprotect it. How to deprotect? So that functional group A benzylic bond, right? PH CH2. So before I told, whenever any compound containing a benzyl group, what is the deprotecting reagent we need? So we need palladium over carbon and hydrogen, and the condition is known as hydrogenolysis. What we will do? It cleave the bond between benzylic carbon and oxygen. Then what we will get? We get this species. So that species is very unstable, so it gets stability by losing the carbon dioxide. How it will leave? It will leave the carbon dioxide like this. This hydrogen transfer to the nitrogen, and CO2 leaves, and we will get our substrate back. So for BOC deprotection, we need acidic medium. So the acidic medium, it may be your Lewis acid or protic acid. So in Lewis acid, it is like AlCl3, and protic acid. So best reagent is trifluoroacetic acid. So when we add trifluoroacetic acid, it will deprotect and we will get our amine back. So how it will deprotect? What is the mechanism? So we have the both protected amine. So when we add trifluoroacetic acid, we get trifluoroacetate and H plus ion. So the lone pair over the oxygen accept the H plus ion. Then it forms H plus ion. After accepting H plus ion, it will form this species. Then that bond will migrate here, and the lone pair and that bond will migrate to this carbon. So what it will form? It form the with a tertiary carbocation. So after the formation of acidic functional group, it leaves the CO2 molecule as like CBZ protecting group and form our gives our amine bag with carbon dioxide. So this is the mechanism how Boc deprotected. So if you want to selectively deprotect Boc functional group in presence of other functional group, we need AlCl3, that is aluminum trichloride. So one example is like that, OSC, and Boc is here. So this is the silyl ether protecting group of alcohol. It is called acetate protecting group of alcohol, and it is known as Boc protecting group of amine. So if we add here aluminum trichloride, it selectively deprotect the Boc and we will get our product like this. So what is this protecting group? It is known as tertiary butyl dimethylsilane. Dimethylsilane, SiMe2, then tertiary butyl. So this is all about the protection of amine functional group.